Okay. So, hey, I'm Steve Sloka. I'm one of the maintainers of Contour. So I know Dana and his team asked to help get kind of a background of Contour, and I thought, hey, maybe we'll just, this isn't the slide I want, but this, I thought we would maybe chat about, Contour, give you a quick architectural overview of what it looks like. And then if you'd like, dig into the code and just kind of see how do we listen for events and what do we do with those events? And then how do we process ingress resources into Envoy configuration? So I'm not sure if you folks had any thoughts around how you want to make this flow today. That was kind of my thought, if that makes sense. But please let me know what you think.
Yeah, Steve, I think that sounds great. What I envision is kind of that architectural view of Contour. Maybe spend some time going through the API. It seems like the HTTP proxy API is the API going forward, at least until service APIs becomes stable. And then, as you mentioned, kind of walking through the code.
Okay, we can talk. Okay, I was gonna maybe skip proxy, but maybe we can show that a little bit if that helps, because I don't want to make this about our CRD. But yeah, we can do that. So let me just pop through. I have a couple. This is like my generic hello world, what is Contour kind of slide. So if you're all familiar with ingress controllers, the goal of ingress is to get traffic from outside the cluster into the cluster. Grab someone here. So again, get traffic from outside the cluster into it, and ingress is the resource we're going to use to define that. So ingress itself is a configuration spec, so it's a way to describe how the traffic should route, and then the controller actually implements that configuration and actually connects the dots and reads that config and says, all right, this request can route to this service or this endpoint within the cluster. I'll skip some of these things here. So here's how Contour is architected. And again, this should match kind of any ingress controller out there generically. You have some traffic from the internet's the canonical example, but this could be anything from on-prem or meaning non-internet traffic. But you come in through and hit some sort of load balancer, which is going to direct traffic to a set of envoys. Envoy is the data path component for Contour. So all traffic is going to route through Envoy and then route to the endpoint. So Envoy is doing all of the lifting of actually moving data around the cluster. The ingress controller Contour is actually the XDS server for Envoy. So XDS is a protocol that Envoy has that you can configure Envoy with. So we implement that. So Contour is the XDS server. So it spins up a gRPC server, which then the Envoy will connect to. And then Contour's job is to look at the cluster here, and it's going to go watch for things like ingress resources, our CRD's HTTP proxy. It's going to look for secrets, endpoints, and services. When any of those things change in the cluster, Contour will then build a new configuration and then pass that configuration down to Envoy. So it's kind of the flow of how Envoy gets its configuration from Contour. Not sure how familiar folks are with Envoy, but the idea here is that on the top, we have all of the different things I just mentioned that we watch for, services, secrets, endpoints, and so on. And then the bottom here, these are all the Envoy isms. So Envoy has an idea of clusters, secrets, endpoints, routes, and listeners. And you can see here that we map things from Kubernetes objects into Envoy objects. So Contour's job is to map services to clusters, secrets to secrets, and so on. And it does this by building this directed acyclic graph, or DAG, in memory. Once it builds up that DAG, then we go and walk that DAG and then pass that information down to Envoy again via that XDS server. If anyone has questions too, you shout out or you can jump in chat. I have chat open as well.
Maybe it's just, I don't want to get too far into the weeds on this. I was just curious. I mean, is the graph structure somehow conducive to just mapping the data structures between Cube and Envoy? I'm just not entirely familiar with Envoy's data model, I guess. Because I didn't know if there was I wonder why you called out the DAG, and it seemed like maybe it was important in terms of the impedance mismatch there maybe between the two data models.
No, so I mean, there's not, conceptually, I mean, they're different, different structs, different data structures that, define what the parameters are in each side. But I guess the DAG that is there, that's more for our proxy CRD because of its hierarchical nature. It's a hard word to say. We basically map, we have a way that we can so let me step back. Yes, ingress today, right? Anyone can own an ingress resource, right? I can have a fully qualified domain, and you can as well. nothing stops us from basically repeating the same domain with path, right? And if two resources insert the same ingress object with the same domain and path, then you've got a collision there.
Mm-hmm.
So the idea of our HTTP proxy, it was previously ingress route, is that you can delegate permissions down. And this is kind of some of the new models in the service API that's coming out. But basically you can say like, hey, I own, it's kind of models after DNS. So I own stevesloka.com. And then I can delegate permissions down to different namespaces. So I can say, hey, this namespace has /blog, this other namespace has /IT. And then if someone else in the cluster tries to replicate that same domain with path, then Contour will see that and throw that out. It enforces that or enables that by building out this DAG in memory. So once we build that up, then we'll walk that, and that helps us implement that. Realistically, for other things, it's probably not as needed. Like if we didn't have that hierarchical permissions, then we wouldn't probably have a DAG memory or data structure there to do that.
Cool, thanks.
Yeah, sure.
Hey, and Steve, is Contour pushing changes to Envoy, or is Envoy polling via gRPC to Contour?
I think there's a little bit of both. David probably have better details on that, but I know Envoy will ask for things. So when it spins up, so we can dig into that too if we want to jump around. But there's as part of Contour, and then this is probably better to do code. Let me show our examples here. So we have some examples here, and we call them examples because there's a number of ways you can deploy things in Kubernetes. So this is kind of like the way we think you might want to do it, but again, it depends on how your network topology and stuff. But in here, what we have is there's a bootstrap, and that's this init container here. So this is on our Envoy daemon set. And what we have is there's a command in Contour called bootstrap. And what the bootstrap does is basically gives the Envoy you have here locally. Let me bring that up here again. Shoot, I lost it. On that screen, you had that Envoy. Where is it here? This one here, right? So when this Envoy spins up, it doesn't know where Contour is. So what we do is we give this, so Envoy has this bootstrap config. So it's like its initial config that you can pass to it. So that init container will go ahead and build that bootstrap config. And basically it has a couple of things in it with some static listeners. But the big thing it has is basically address to Contour. And you'll see that here. If I can get my windows right. Here, so we pass in the XDS address, which is where Contour is, and the port it's listening on. And then by default, we have some certs. So we've encrypted our communication between Contour and Envoy. But basically, this is what comes out of there. So if we want, we could look at that. If I get my pods here, and let me go ahead and grab. It's not ready. That's not good. Let me change. Let's go ahead and look at that. It's what I guess you can believe me. There's no point to look at it now. There's a shared data volume we have to get that config in there, but it's not important again. It's just a bunch of JSON, right? So that JSON then describes, hey, this is where Contour is. So then whenever those envoys start up here in this diagram, they'll go look for Contour, and then they'll ask Contour for its initial configuration. They'll say, hey, give me all the listeners, give me the routes and things. Whenever Contour sees things change, then Contour will signal back to Envoy and say, hey, your routes have changed. And then all the envoys will get all those updates and messages. But they're not polling. It's a gRPC connection, so it's a rich connection that can communicate back and forth. Does that help?
Yep.
Yep, okay. Cool. So that's the generic, overview of how ingress and stuff works. This slide talks about, we have Grafana metrics and stuff, and Prometheus metrics. So we do expose all the metrics from Envoy via Prometheus, and then Contour itself has some metrics as well that we expose. Again, we could demo and look at if that's interesting or not. So do you want to talk a little bit about our CRD, and then we can just look at the code, if that makes sense?
Yeah, I do have one question before we get into the CRD. You mentioned that Envoy is deployed as a daemon set. Is that correct?
Yes.
Okay. And Is there some background there that you can share? I mean, is there options where if I'm a user and I say, well, I really want to restrict ingress to, just a specific number of nodes?
Sure. So Contour, there's no restriction on having Envoy be a daemon set. So our generic deployment model is Contour as a deployment, and we run 2 or more of those, and then we run Envoy as a daemon set. And then the daemon set gets run with host networking. So here in our Envoy here.
Is it fair to say then, I mean, that the Envoy deployment is effectively user managed? Like Contour itself is not actively managing like an Envoy deployment structure of any kind or a daemon set itself. It's up to the user, a cluster administrator or whatever, to install Envoy essentially to use in conjunction with Contour. And there's no automation around the management of Envoy.
Correct. Yeah, it's not
right,
like
yes.
Contour is an operator and you have
right.
like an Envoy instance CRD that you're going to create to go spin up a number of those, right? No.
Right. So okay. So the fact that there is a daemon set as like kind of the default supplied manifest or whatever isn't like there's nothing you're imposing on the user there. It's just that happens to be the tested way to deploy it as like a way that you can deploy it essentially, or
Yeah, I guess what we found is like Envoy scales very well, and it consumes lots of threads and lots of network. So usually what happens, like when we did some load testing, like I'll max out the data pipe or I'll max out the threads and CPU on a server before I max out the instance of Envoy. So if you needed more capacity, running more Envoys on a single node doesn't so much help. You know what I mean? So like I have a whole bunch of traffic. I'll go to run 10 instances on each node. It's not going to help you as much as adding more nodes to your cluster, I think, and adding more network bandwidth that way. So that's kind of why we went with this model of having Envoy run as a daemon set. But there's no requirement to do that. You could run Envoy as a deployment if you'd like. It's not a problem. We used to run Envoy and Contour co-located in the same pod for a while. And then they just talked over localhost. And then we split that apart so we could manage the lifecycle of Envoy different from Contour.
Okay, yeah.
Yeah.
Is it, okay. I consider this kind of topologies, I guess. There's like a recommended topology or an out-of-the-box topology, but there's no dictated topology, I guess.
Right, yeah. That's why we call it examples, because it depends on how different folks do networking different ways. So it's kind of, we don't want to impose it has to be this way. So it's very flexible in how you do it, but this is kind of what we think would be a good topology to use.
Hey, great. Thanks for some of that background.
Sure. Yeah. Another good example of that is this. We get a lot of questions on this. Because Envoy and Contour are split apart. That communication, it used to be before we solved it, that communication was unencrypted, which isn't a big deal until you start adding TLS certs to your envoys. So then anyone could basically intercept that traffic possibly from inside the cluster and pick apart your certs. So we now secure that, and that's what those certs here, you see that this gets referenced. By default, out of the box, we give you this job, and this job will go ahead and create generic certs for you. And this is another one of those commands off of Contour. Yeah, Contour cert gen. So it'll just generate self-signed certs for you, but there's no requirement that you have to use this job, right? All Contour wants or recommends is having certificates. You can turn off the encryption and say, hey, I want to run insecure, and it'll work fine. But we thought folks would maybe want to have their own TLS strategy or their own cert management strategy in-house, so they might want to use their own. So totally a possibility, but this isn't required at all. Okay, cool. Any other questions about anything, or what do you? I guess I'm open to see how this wants to flow. Do you want to talk about some proxy things, or?
Yeah, unless anyone else objects, it would be nice to just walk through the CRD, and I've looked at it a few times. I think I've got a good understanding, but coming from you, I think would be valuable.
Sure. And there are, I guess I can link to out in Slack. I've done this talk like a bunch of times in terms of what is proxy and how does it fit and function. So if you want more in depth, we'll do a quick one because I want to kind of get in the code maybe just to make this a different session. But so the big thing we wanted to solve, and I can make this bigger, we wanted to solve was Ingress v1 beta 1 before all the v2 stuff came out, was we wanted to be able to solve this idea of multi-team clusters. And the idea here is that having, again, multiple users in the cluster self-manage their own Ingress resources, but do that in a safe manner. And we do that through this idea of delegation of routing. That's where that DAG came into play. So we want to be able to delegate path and header combinations to other namespaces within the cluster. We also want to be able to define things without annotations. So today we've got this annotation sprawl, like service weights, load balancing strategies, 301 redirects on from insecure to secure connections. All has to be a annotation today, just because the Ingress spec is just not well defined to have all those different pieces and parts. So we wanted a way to do that. We wanted a way to have multiple upstreams. So when you define an Ingress resource, I'm going to proxy to 3 different services in the cluster and have it load balance across them. Maybe I want to do a blue-green deployment with that, or a canary deployment or something. But again, today with Ingress, you can't do that very well. Another thing that came up from users is this idea of TLS certificate delegation. I guess we can talk about this as well. But being able to separate where your secrets actually live in the cluster and then where users can actually use them. So this delegation structure lets you, tuck your actual secrets and keys away in one admin namespace, but then let a user reference it from another one, but not actually have to have physical access to that through kube control. So those were the highlights of why we went to this proxy thing. And here's again that example, which we talked about before. I have, a team in namespace A, a team in namespace B. They both reference /blog, both for the same host, projectcontour.io, and they reference different services in the cluster. So like what happens when this gets processed? They have the same host with the same path. It's undefined. It's basically, we've seen lots of folks take down their clusters in production because they didn't realize they were doing this, and they broke different paths or things. So that was our main goal of our Ingress route security initially, and then we wrote that as HTTP proxy. So I have some examples. Okay, so here's the idea of delegation. Originally this was modeled after DNS in a way. So if you think of like a name server, right? So I own stevesloka.com. That's my website. You could go ahead and create your own a record and says, hey, I'm stevesloka.com. Send me all the traffic. Nothing's going to route to you unless someone who actually owns that has authority to actually send that record to you, right? So anyone can create any number of records in the world, but it only matters who actually owns that. And this is kind of the idea of how this delegation model works. So here I have this root proxy, right? And it owns projectcontour.io, this fully qualified domain name. And someone else here is called the blog, and they're a child of the root. And they say, hey, I'm going to give authority to projectcontour.io/blog to this different namespace or this team. So the idea is that if someone else comes along, let's give it, okay, so it's authority is given from the root. So the root passes off that authority and gives that permission. If someone else comes along and says, hey, I own /blog for the same domain, serve this traffic up, Contour will throw it out because it doesn't have authority for that path and that domain name, right? And we do this idea of an include. And we can show you that in better detail here in a second. But an include is the way that you actually pass off that authority. You actually include these different permission sets to these different proxies, and then that gives them that authority to use those different paths. Once this team owns, in this example, /blog, they can go delegate anything after /blog, right? Because they own that /blog path. So they could delegate /blog/foo to a different namespace if they wanted to, and so on and so forth, because you're letting them self-manage it, if that makes sense. Any questions on kind of how this works? I can demo this if you'd like.
This is good, thanks.
Cool.
I don't know if I need to see a demo. I think you laid it out well.
Okay, cool. And like I said, yeah, let's skip the demo on that because I've walked through, I've done this a bunch of times. There's probably a bunch of videos out there that we can link to show this off, where we do delegation to teams and then canary things in blue green.
Steve, do you mind going back to that slide just one last second?
This one.
Yep. So someone creates a HTTP proxy for the blog, path, and it's essentially not serviced by Contour until the owner of the root adds the include for the blog HTTP proxy.
Right. Yep.
Okay. I just want to make sure I understood that quickly.
Yeah. Yeah. So the whoever owns it's not always the root. I always show the root. In this example, the root where the fully qualified domain name is defined, it passes off that through an include. So it'll say, hey, include this proxy here, this blog. This is the name of the proxy. Naming that proxy in that namespace, and then they get the path /blog. And then from there, someone else could create a new one. And then this child one here could delegate another further path or header to somewhere else if it'd like to, or within itself. You know, they could delegate internally as well.
Okay. And how is the root identified as a root?
It's just for the sake that it has an FQDN in it.
Okay.
Yeah. So Contour. So we went back and forth on should we have one CRD, two CRDs, three CRDs, and we landed on just having one because the simplicity of having one kind of outweighed the complexity of having multiple.
Yeah.
So there's confusion, I guess, sometimes in, you know, like you said, what is a root proxy and what is a child proxy? But we wanted to be able to have like the canonical example like today of ingress, where you can just deploy one resource and it serves everything. And you can do that today. You can have one proxy in your whole cluster, and it can serve as many paths as you like.
Great.
Yeah.
I've looked at this delegation a couple times and started to understand it, but this helps a great deal. Thank you.
Sure. Yeah. It's one of those things where it's tricky to explain, and once you get it, it's not too bad. And by no means you have to use this. You know, we still support regular ingress as well. So if you want to use just v1 beta 1 ingress, and soon the service API stuff, then Contour will support that. That's no problem at all. Sometimes like I get the thought that we have to use RCRD, and you don't have to. Cool. So that's all the slides that I had in terms of chatting about stuff. Do you want to look at Contour itself now, like the code?
Sure.
Okay, cool. So is this big enough for folks to see? Let me bring up
it looks good.
I can see it just fine. Yeah.
Okay, cool. I made this a little bigger too here. Yeah. Cool. So Contour has a couple different commands. I guess I'm trying to think of where to start. How do you chat about this?
Start at the entry point.
Yeah, so we'll start there. Yeah. So there's a bunch of different commands that it has, right? So this is the main point, Contour here. And there's some ways to get configuration into Contour itself. So Contour will take some command line arguments, and it also takes a configuration file. So we're starting to, you know, push things off to config files because we got kind of overwhelmed with flags, and then it sort of seemed like a good way to do that. So yeah, I'm trying to think of. So yeah, so there are a couple different commands. So one is Contour serve, and that's the main one here. This is the serve context. So serve is what actually starts Contour up when it's running as the gRPC server. When you run the Contour serve command, this is what happens in the deployment of Contour. That command is going to start you know, a connection to Kubernetes and start a bunch of watches. And it's going to start the watches on services, endpoints, secrets, all those different things. This is the meat and potatoes, everything. It's going to spin up that gRPC server to serve context back to Envoy and everything. That's what the serve one is for. We have the Bootstrap one, which we touched on shortly before. Bootstrap is where this runs as an init container in Envoy. So the job here is to produce a small configuration file for the Envoy living in that daemon set or wherever that's deployed. So then this gets passed again as a init, and then it shoves that configuration down to Envoy. So basically it tells it where Contour is in the cluster. And by default, we use the service address of Contour for it to go look for the service name, which is by default Contour.
Hey, Steve, really quick, you said it
yeah.
shoves the Bootstrap config down to Envoy. I'm trying to remember how that works. Is it mounting? Is it creating like a config map and then mounting it into Envoy? Or
yeah.
do you mind covering that just briefly?
Yeah. Yeah. So here we'll go to our examples here. So here is the init container. So what it does is it mounts this Envoy config to /config. And then Envoy config here is just an empty dir. So because it's a init container, this will have to run first. So this one will start first. It'll generate that config. Actually, we can do it here on my machine. I forgot we can just run the command locally. So we'll generate that that configuration, and it gets written to /config. Once we write that /config, the Envoy pod, which is here, set of containers, it also mounts that same config map of that empty dir file. And then it references it. So here's where it mounts in that same config map or directory, empty dir directory. And then here is where that gets passed here. So envoy.json is that config file that the init container wrote.
Is Envoy reacting to changes in that file?
No, it's not. It's only read once.
Right. It's just
sorry. Is it
Bootstrap,
blocking
right?
on? Sorry, I missed something. Is like Envoy blocking on startup, like waiting for that file to exist or something? What's gating the Envoy process startup on the creation of that file?
Just for the fact that it's an init container. So the init container ensures that will run first. So the bootstrap should happen first before any other containers in that pod will start.
Oh, sorry, I see. This is an init, okay. This is an init container for the Envoy deployment. Yeah.
Correct. Yeah.
Yep.
So the contour like
recycling
image.
the contour binary to run another command that generates the bootstrap config. Okay, got it.
Yep, exactly. Yep. So we have just one image with multiple commands in it.
Yep.
Essentially.
Cool.
Yep.
Okay.
Yeah.
Thanks.
And here I can actually, I can probably run it here and we can see. All right. So if I do contour, here's all the commands that we have. This is probably a better way to look at it. So here's bootstrap, right? So I could say contour bootstrap. I gotta pass it a command. Bootstrap. I don't have it in history. It's a bad demo there. I think I gotta give it. Let's see what I gotta give it. XDS address and stuff. So we can do XDS address is something, and then XDS port is something else. Oh, path. What's path? Oh, that's weird. Should know this.
Looks like that would be the config file.
Config Envoy JSON.
Oh, okay. Yeah. Here, let's do this. So temp config dot. I don't know. How about envoy.json? Or should it be for rapid help in there? Okay, cool. So then let's do that. Code temp config.json. All right, there we go. And then can I do this pretty thing? I don't have it installed.
Format document. That's the command you're looking for.
There we go. Boom. Cool. Thank you.
Yep.
Cool. So this is what gets set up in the Bootstrap. So we write out some generic, a generic cluster, and that cluster is the XDS server for that Contour is, right? So here you can see that. So Envoy has the idea of clusters, and the cluster is kind of like a service in Kubernetes. And then a cluster has a set of endpoints, which match endpoints in Kubernetes. So we create a cluster called Contour, and we give it an endpoint, which matches that address that we gave it. So I gave it this IP address. This could be the service name in Kubernetes as well. So this is the endpoint now that cluster is going to back. And then down here in, where do we tell it? Somewhere we tell it to use this cluster name Contour for its XDS server. Here we go. So here we go for your Envoy gRPC. So this is telling it, hey, go use the cluster called Contour, and then that Contour then uses those endpoints to go find it. So this is what tells Envoy where its XDS server is in the cluster. For LDS and then CDS, and then we this is right here is hiding the admin domain. So there's an admin domain or admin web page in Envoy, which is actually pretty dangerous. You can like kill Envoy from there and restart it and do crazy things. So this is just making it only listen on localhost, so no one can get to it from outside the cluster. And I think we also create a static listener for metrics in here somewhere. Here we go, stats. So we create a generic listener for stats. So we say, this is creating the listener for it, and then there's an implementation for that, service stats. Somewhere I thought. We create that. We might have moved out the code. So I'm curious why this is here now, but we'll figure this out. Does this make sense? This is
I get
all that
what you're doing. Yeah.
Yeah, this is all we pass. And there are ways folks have customized this. I wouldn't recommend it at first, but because a lot of the other things are dynamic, so all the other listeners and clusters and things come dynamically through the XDS interface. But this is, I think when Contour started, we used to actually poll for XDS changes, but now we can use gRPC for that. Oh, this is it. This is the stats endpoint 8001. That's what we exposed to that listener. There it is. Okay. So that is the bootstrap command. Let's see what else we have. Again, certgen, that helps you generate certs. If you'd like to have it generate certs for you, that's what that job was running. So again, that we give that generic job that you can use to generate certs for you if you'd like. Again, not needed or not required, but it helps just to bootstrap if you don't mind where the certs come from. That's baked there into the command. There are a bunch of CLI commands. So one of the things that's interesting to see is if what are you sending to Envoy? Like, what are you sending for clusters and for endpoints and things when you're debugging? This can be useful in certain cases. Probably when you're getting started, it's not as useful, but it's a way to see, what clusters you're sending down to Envoy and such. So I could say contour CLI CDS. This is going to bail because it doesn't have a connection to an endpoint. So I could do this. Let me go ahead and port forward. Make that a little bigger for you. I can port forward to my Envoy pod, or Contour pod, I'm sorry, over 8001. So that's the generic port that Contour listens on for when Envoy connects. And what we'll do here in the CLI now is we'll do the same thing. You know what? I have security on. That's not going to work. Let's turn it off. So that won't work because I have the connection secured. I'm not passing it the certs. So that's no good. I wonder if I can run it. Sorry. Or if I can exec into it. No, I can't. Sorry, that's a bad demo.
So you did show. So you showed us, how Envoy gets bootstrapped and how that works on the Contour side and how you would deploy them. Now they're up and talking. Mm-hmm. And now I'm curious to see what the actual processing model looks like. Like how is the internal state being built up and then served to Envoy, et cetera?
Sure. Okay, cool. Yeah. Yeah, so as part of the serve command, let's go back to here. So serve will go ahead and get a client, a Kubernetes client using client Go.
Oh, sorry, and just to pause here for a second. This is this is an endpoint that's serving connections to Envoy.
What do you mean?
Sorry, this function, it's do serve, serving what? Is this I missed something about the model, the communications model with Envoy. Is Envoy, are you establishing a gRPC connection up front and now it's polling you occasionally, or do we push out changes? How do we get into this function?
Okay, yeah, sorry. So do serve is the Contour serve command. So here, let's go back to our example here. If I go to the Contour deployment, when you run this, basically the args are serve. So you run the Contour command, which is Contour. So I would say Contour serve. And okay. that here you can kind of see it happening here. It spins up. So
this is the entry point of that command. Okay.
Yep. Yeah. So this
Sorry, I missed that.
No, that's fine. Yeah, I know. Sorry, I didn't practice this because I wasn't sure where to go, and I'm sort of winging it. So I apologize. It's confusing to folks.
Oh, no, this is all great. Thanks.
Okay, good. Yeah. So do serve so I'm here in this Contour command or command Contour, and then do serve. It starts up the serve command inside the code. So the first thing that when you say Contour serve does is it goes and creates some connections to Kubernetes, and we use that using client Go. And we recently just switched to using the dynamic client for our CRDs, but we're still using the generic informers and such for all the V1 objects in Kubernetes. So secrets, services, endpoints, all those different things. So if you're familiar with Client Go, this will go ahead and create basically based on your kube config. And if you're in the cluster or out of the cluster, get you a client to talk to Kubernetes or the config. And here we create the core client and then the dynamic client. And then we create all of our informers. So informers are used to go and do the watches on those resources. We can skip it through a couple of things, but this is just setting up all those different watches, setting up the Prometheus endpoint for Contour because it exposes some Prometheus stats as well. Event handler is probably the meat and potatoes of how we process from events from Client Go into Contour itself. So we can dig into that here in a second. But this sets up all the different components of that it needs in terms of its loggers and its metrics things and this hold off delay, which we can talk about here in a second. And then the builder is the other component too, which we'll talk about. So this is actually what builds up that DAG, that directed acyclic graph in memory. And this is where we kind of process different types. So Contour will process, V1, beta 1 ingress objects. Soon, whenever V1 comes out, we'll process V1 ingress. We can process ingress routes. We can process HTTP proxies, and soon we'll be able to do the service APIs. So the person that helps us kind of convert all those different types is this thing called builder. So builder takes these different specific types and then writes them to a generic type internal to Contour. I should build a diagram on this. But basically, once you get all those objects written to Contour's internal speak, then from that point on, it's all the same logic. You know what I mean? So we basically convert all that into Contour data structures. Once Contour has it, then we can just pass that off to Envoy. So the only hard part when you implement, say, the new service API spec is going to be writing this builder spec to understand how builder works and then convert that to Contour things, and then it should all work. So we'll probably look at that next after the event handler. Blah, 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 blah. Here's all the informers that get written up. This here is if, so they moved the group from, what was it, networking, the group, it was extensions.v1 beta 1 to networking.k8.io. So this is that flag. So if you have a newer cluster and you've turned off the old one, so we don't throw a whole bunch of watch errors looking for V1 beta 1 ingress, this will do that switch there for you. Blah, 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 blah. This is just boilerplate stuff. Cool. So that's how that works. Contour does have leader election, which I guess is important. But leader election is only dealing with who can write back status to the API. So if I look at my cluster, if I get proxies, you'll see here I have an invalid status right now. This is me testing and messing around. Only one, so we can deploy multiple contours and they'll all send traffic to any envoy in the cluster, right? So I can have, 10 different envoys running on 10 different nodes. And then I could have, say, three different pods or replicas of Contour running. They'll all listen to the cluster, they'll all process events, and Envoy can connect to any of them to get its configuration. But only one of the contours is going to be elected a leader, and that means that only one can actually write status back to the API. And today this is only for our CRD. Right now there's a work in flight to have our ingress objects actually write back status. But that's all that leader election is done for, is just to be able to define who's the writer, so we don't have multiple people writing changes to the API. So these have this work group thing that gets spins up all these different pieces and pipes. There's a gRPC server here. Where is it? I think it's here. Yeah, gRPC. So this is where the gRPC server gets spun up for Contour to serve that endpoint to Contour or to Envoy. Yeah, that's where that happens. And then this handles the sig term. So if it receives a sig term from Kubernetes, this tells it to shut down, and that's it. Okay, cool. So once we spin up all that stuff and we hook up all those events, I know this is super fast. This isn't helpful, but a couple of things happen. So let's go down to our internal. So I'm trying to think of where a good place to handle this. So it's not going to be DAG. It's not going to be that. So here's the XDS server. So this is where you can see where you can register for the clusters, endpoints, listeners, and routes, and secrets. So these are all the different XDS interfaces that Contour is going to send back to Envoy. Yeah, this is the V2 XDS gRPC API is where all that happens. And then I think this stuff is just managing the chatter between Envoy and Contour from behind the scenes. Yeah, so here's where we get ACKs and NACKs and stuff from Contour. This is an xds.go and the gRPC package. So this is all the specific stuff for that. So when an event comes in, let me find the handler. Yeah, so you create the listener in serve.go, right? And we create out the different informers. And the informers are client Go isms that are going to go and create watches on the API. So when a service changes or an endpoint changes, we'll get that event back from client Go. All those get registered to this event handler. And we can see that here through in serve.go. Yeah, right here. So we register this event handler. Again, this is for, let's go to services here. That's an easy one. So if I go into services, we basically add that informer and register that event handler. When an event changes and happens, we'll get a callback here on this event handler. So here we have the on add, on update, and then on delete. And again, this is the same event handler across any of the objects. So you can see that we're getting passed in an interface because it doesn't matter what type comes through. So on add, update, delete will happen here. That calls update of the event handler itself, which is here. So if we dig into that, that's an interface, which is this person here. So this is our event handler. Pretty sure it's the only one. Yeah. So here on change, what we can do is we will go ahead and, now there should be a switch here. I'm missing one step. Sorry, folks. It's funny how you do this every day and you lose track of where things go. So cache handler, so the event handler, where is it? We're going to hit the DAG here in a second too, which is update. Update gets called in the event handler. Yeah, so yeah, okay. There's a big switch. Here we go. Nope, that's something different. This is updating the DAG. So this event handler here processes through. I know I'm going fast. This is the event handler running loop. So the events come in through client Go, they get pushed onto a cache. Once those change, then this is where the actual processing kicks off. So this event handler then runs this event handling loop, as you can see here. What this job is for is it says, all right, so I got an update. Initially what Contour did, so Contour received an event, it goes and it processes through and builds out that DAG. So it builds out like a canonical example of what all the configurations should look like for Envoy. Once it has that, it passes that down to Envoy. Now, the problem we had was every event would build a new version of that DAG, right? So if you had a busy cluster, a service changing, an endpoint coming or going would cause that a change. So we were constantly rebuilding this DAG over and over and over and over. And for the most part, it was happening, we're rebuilding it too often. So what we have is this idea of this back off timer, right? So what we'll do is we'll wait so many seconds or milliseconds and let all the events come in, and then we'll just go and process that at that time. So Contour isn't, I'm trying to explain, Contour doesn't need to have the events happen in real time. It just needs to know like, hey, at this point in time, go create your configuration based on what it knows about, right? So it has a cache of all of the services, endpoints, secrets, and all those things that exist. And when it builds that DAG, it just builds it based off of what it knows in those caches. Does that make sense? So the idea here is that I can build a configuration, and I can wait so many seconds, right? And a whole bunch of events can come through. And then I can say, hey, go ahead and build another one. And then it'll build it based on the sum of all those events happening together, instead of building configuration off of each change incrementally. If that makes sense. Does that make sense to everyone?
Yeah, we did the same thing in OpenShift.
Well, although I want to be clear about something. It sounded like you're almost implying that the transitional states between the edges of that window were significant. Like you're not collecting changes and then applying them serially, for example, on an interval, right? Or after some total. Okay.
No,
It's just like
no.
it's level driven, as in like whatever the current state is at a point in time, you rebuild it from that, regardless of
Right.
what prior states were. Okay.
Exactly. Yep. Yep. That's a better way to say it. Yes.
Okay.
So then you can make that window bigger or smaller, right? So if you had a really busy cluster, you could, where you could cache through lots of events, and then you could process it depending on how fast you want to get it.
But I guess like is the nature of the update then insignificant? I guess is it basically just triggering a rebuild, and like the type of event doesn't necessarily matter. I guess it's just like something significant happened and you need to rebuild.
Right. Exactly. Yeah. It doesn't matter if it's a secret or an endpoint or a service coming or going. Yeah. Right. It's just at some point in time, hey, something changed. Let's go rebuild a new configuration now and then pass that off.
Okay.
Yeah. Yep. Yeah. So you could. Yeah. Exactly.
And then on startup, for example, so like what is it? Just like this is like we're talking about the reactivity to the event pump, but like on startup, then what's happening with the informers there? On initial startup, is it sending you events for all the objects, or are you doing like a list, iterating over them somewhere else? Like,
yeah, I think on startup we wait for the caches to fill first, and then we kick off the process. So somewhere here, there's a wait for XDS, wait for no.
yeah, I guess I can't remember how the informers. I haven't worked with the informers directly in a while. I can't remember like whether this after the sync occurs, does that mean that you're going to get like an event now for every object for your initial sync, or what?
Yeah, when you first start up an instance of Contour, it goes and gets everything from the cluster. So it gets all the services, all the endpoints,
right.
And that can be expensive. Yeah. So by default, what we do is on first start, we wait for all those informers to get all the events first. So basically, it's going to fill up all of the caches in Contour, and then once those are all filled, then it says, all right, now go and do it. Because the problem happens is you'll get
Yep.
partial configs as you do that. And then what can happen too is you can actually break yourself. So like if you get, say you have like a running Envoy with all its configuration, and then restart Contour. Contour is going to then start, and if it builds configuration slowly off of what it sees, it can then delete configuration that's existing in Envoy. Do you know what I mean? Because it doesn't have all of the data yet. So if you had, say, 10 different routes and Contour processes and only has 5 at that time, then it's going to say, hey, Envoy, kill those other 5 that don't exist, because it doesn't know about those 5 that were there before.
Yep.
So the idea here is to mitigate against that. So let all those caches fill up first, and then pass all. Once you have it all, then say, all right, now go build the DAG, and then pass that configuration off to Envoy. And that's what this is meant to do here. Yeah. Okay, cool. So we're looking at, so we had the cache handler where we were updating all the events. We had this handler here where the events came in. We should show you, not that. How are we on time? Oh shit, we're not doing that well, are we? Okay. So let's skip ahead. So
you put all this code here.
I know. This is fun though. I don't know. Hopefully this is helpful. So Contour has a bunch of caches, right? So in this cache handler, there should be, so here's a listener cache, a route cache, a cluster cache, a secret cache. All those get filled up of data, right? And then what we do is we go build, this builder gets kicked off. So the event handler says, hey, go build a DAG. And then in here, this is that basically the kind of adapter in a sense, right? So this DAG builder says, go ahead and compute virtual hosts, go work on the ingresses, the ingress routes, and then proxies. And these are done in this order because we want proxies to trump anything configured as ingress routes, and ingress routes to trump anything with ingresses. So this is the meat and potatoes of where these go. So if I look at compute proxies, it's going to go look through all of the proxies that it knows about. And again, that's based on what it has in its cache, right? And it's going to say, hey, go compute a proxy. And then this is where it's doing the logic. So it's saying like, hey, if the virtual host is nil, then we're going to mark that as orphan because no one's delegated to it. Because I guess at this point, I guess I missed that, huh? We've processed all the roots by now. I believe that's here in this one. No, not that one. Valid proxies come from here, I think. yeah, so this is where we pick out all of the routes, right? So for all the fully qualified domains. So this goes and looks for all the routes that exist that have a fully qualified domain. Again, it's processing logic through it from there. Once we have the routes processed, then we can go process all the children. So it's going to go and process through. And look for things like there's a way we can limit where ingress routes live. You know, if you define it outside of that, this will go away. It's going to look for TLS secrets. So hey, you know, if you said, hey, this should serve a TLS endpoint, again, it's just doing all the logic to figure that out. Now, I guess where this comes into play is after it does all of this stuff, you'll see this add routes method, right? So it's going to do a bunch of checking of errors in logic and whatnot. And then it's going to go ahead and compute those routes here. So here it's going to go pick apart and get like the actual route. So /blog, /foo, /whatever. Once it has those, it gets this method called add routes. And this just adds it to this vhost thing. So this vhost object now is, it gets returned, but this is what this route object is now part of the DAG, right? So this is contour speak. So we're taking, you know, all those ingress routes, proxies, all the different types of things, and we're converting them into this internal structure that Contour manages. Again, we have clusters, we have all this different stuff. I guess inside the route. So route is there. What else do we have? Other things, I guess, retry policies and stuff. So we're going to convert to the contour speak, I guess is what I'm saying. Once it's in this generic contour speak, then we can process everything after this is all the same, right? So we're mapping everything into here. And that's the job of the builder. So you'll notice in here we have, there's, what was it, process ingress routes, everything's in here, I guess. Here, right, all the different types. So once we go and build the service APIs, we'll have a be, you know, compute service APIs or something. Do you know what I mean? And then we'll have all the logic in there for that. Once it gets into the DAG, this thing will build that out. So this is all of the pieces and parts that make up that DAG. Then it goes and it hits the next step. So this build, we'll call back to this update DAG. So this event handler here is where before we were waiting for the time off, or the back off timer, this gets called, we go ahead and build that DAG. And then we tell the cache handler, hey, you changed, something's different now. And then this will go and updates all the different components. So at this point, let me go back here. After this builder.build, this DAG here contains all the configuration for your cluster. Everything that's processed, everything that's valid, everything that should get passed down to Envoy is in this DAG now. And then once, it's not, I guess it's not Envoy speak yet, but it's ready to go. It's been processed and validated and everything. Cache handler then will go update that. So let's go look at routes maybe. So cache handler update routes, we'll go and visit the routes. So we'll dig into that one. And then this will go through and pick apart all of the different pieces, right? So we sort the routes. So we put longest first, right? So Envoy will route to whatever. So if you had like /blog or /blog/foo, which one should route first, I guess, if you just entered /blog. That's a bad example, I guess. But we sort them longest first, right? So the most defined one will happen first. And then in here, this gets passed off to this visit. So where do we build out? Yeah, so here we're building, where are we now? We should be in Envoy. We pick apart each piece and then build out the Envoy route. And that's here in this Envoy package. So if I look at route, we can build out what Envoy speaks are. So like a route match is an Envoy XDS type, and it can have a path or a regex. So this one has, if it has a regex, it passes a regex in there. If it has headers, it passes headers. So this is what's going to take the DAG information. So see the input here is a DAG route. And then this will convert that DAG route into an Envoy route, right? And we return back this Envoy routeism, or this XDS route type, which is, again, this now is in the Envoy XDS server. And then that gets built up into a cache. And then that's what the XDS server will serve back to Envoy. I feel like I'm confusing myself, so y'all can't be following along that well either. But the goal here, I guess, there's an Envoy package and there's a Contour package. Right, the goal is to convert the information into this DAG, and then you convert that information into Envoy isms, right? So the Envoy package is mainly meant to map things from the DAG into Envoy things. And then the things in the builder is to map other objects into the DAG objects. And that's how we can separate those pieces apart.
I know there's only like literally 2 minutes left or whatever. Can you at least like show where like how does stuff actually get shipped into Envoy over the wire?
Sure, yeah. So in, oops. So in the server here, this spins up all these items, and then those caches get passed into here. Let's see. Where are we? Because this is the server. Where's the? Those are that we map.
Just generally, like, is this server like receiving notifications from internal changes and then sending those out over the gRPC connection?
Yeah. So
in response to updates.
Yeah. So this message here, this is processing discovery requests from Envoy. So you'll see here, there's a forever for loop here, and then this will go ahead and this receives requests from Envoy when it asks for things, but then we can also push things down to them.
So are we pushing on update? And what's the granularity of information? Like, so it's like a single endpoint changes in a service, let's say. It's like, how much information has to be sent to Envoy to do that?
If an endpoint changes?
Like, are we sending is it sending like deltas, or does it have to resend the whole graph? Like, what's the?
I think we're resending everything. Because we talked about, so there are some things, we've had some folks with memory issues where in a high volume cluster, we consume lots of memory. And part of that was because of, we're sending data and resending the same things over and over. And when Envoy receives a change, it makes a new change in memory. This is how it can do things hot. So it'll spin up a new set of configuration memory, and then let the old connections drain off. And then once those drain off, then it releases all that back. Mm-hmm. Well, if you send like lots of changes all at once, Envoy then spins up many copies of all the data. And we've had some memory issues with that. Some things we've mitigated that around was sending stuff down to Envoy in the same order and not having Envoy have to figure out, rematching things up. I think
but does it have the capability, like if as a client you wanted to, you could like coalesce and batch changes?
Yeah, I think in that XDS protocol, you can manage how you want that to work.
Huh, okay.
The granularity of that, yeah.
Okay, cool.
Some gotchas, yeah. We can bring I know Dave Cheney's done a lot of the XDS stuff on this, so I feel like I'm not helping answer your question all that well. But yeah,
this is good.
Yeah. So there's lots of things around this XDS that can get tricky and it's confusing at times of how the data flows around. But this is where we're responding to discovery requests here in this xds.go. I'm thinking of, I forget where we map up, and I'm happy to go longer if folks want to go longer. But up to y'all. If you need to balance, that's cool. I thought in here we register the XDS things, but return serve. Here, resources, I think. Yeah, okay. So, yeah, so here, yeah, this is what it is. So in UP API resources, yeah. So this XDS handler gets passed in this map of resources, and that comes from this event handler cache. So remember when we got, yeah. So in the cache handler, when it gets all the updates, these are the caches that get populated internally to Contour. And then when those get populated, we pass that off to the XDS server, and then that maps those caches to the XDS address where Envoy looks for things. So those get passed in. So then when the discovery request comes in, it'll change that information down through those caches. So we basically refill those caches back.
Good, interesting.
Cool. Anything else? And again, if you want to, if you got a balance, that's cool. But if folks, anything else you want to look at, hopefully this is enough to go poke around. We can do some more if we're interested.
Yeah, I think this gets us going in the right direction, and I think it'd be a good idea to wrap things up and get a chance just to kind of digest the information. I'd like to go back and dive into Envoy because it has been a while since I've worked with Envoy.
Sure.
And maybe we circle back together, and if we think that maybe there's a few topics that we could have a follow on, and we can discuss those details.
Okay, cool. Very cool. Well, thanks everyone for coming. Appreciate your time. So this is fun. Give me a shout again if I'm in the Kubernetes Slack. If y'all have questions, we can chat there, or however, let me know.
I really appreciate it. Thanks.
Yeah, thanks, Steve.
Yeah. All right, take care, everyone. Have a good afternoon. We'll see you.
You too.
Thanks. Bye-bye.